Section 3.2 continued, concavity and points of inflection are what we're going to continue on. For this, concavity is used to describe the way the curve bends. For any 2 points that lie in a curve, if the segment that connects them is above the curve is said to be concave up. And if it's below the curve, then it's said to be concave down. For this concavity, if we look at these two graphs that we have right here, I know that the way that this curve bends, if you look here, from here all the way to here, the curve is bending upwards, so that's why we call this concave up. And so we would write concave up. And for our intervals that we use, you also use your x values. So we have x values from -infinity to infinity is where this is concave up. And so what that was talking about before with a line segment connecting two parts of the curve, and if it's below the curve, it's concave down. And for any 2 points that lie in a curve, the segment that connects them is above the curve, and then concave up. It was just talking about if it's above the curve like this, the concave up. Now, for the next one, and it's easy to look at this too, looking at the way this is bending, notice that it's bending downward, so this is called concave down. And the interval, which is concave down, is from -infinity to infinity. Again, these are not points, these are the intervals, and we're using the x values, just like when we do increasing, decreasing, and constant intervals. The next thing we need to talk about are points of inflection. A point of inflection is where the curve changes concavity. If we look at the next graphs here, we can kind of tell where our graph is going to be concave up, concave down, and the place where it's going to change concavity, which again is called your point of inflection. So if you look at this graph, you'll notice that from -infinity to somewhere in here, it looks like our curve is bending downwards. And then from this point to infinity going this way, it looks like our curve is bending upward, so concave up. Now, we have to figure out what is that actual point of which our graph is changing. If you're given a graph, you can find it by using your maximum and minimum points. So if I look on my graph here, I can see my minimum is at 3, -2, and my maximum, which is right here, is at 4, -4, 4. Well, basically what you're doing is you just need to find the x value that's in between those two, because that's the place where your concavity is going to be changing. So if I take my x values, how do you find what's in between them? You add them together. So -4 plus 3 divided by 2, that gives you the middle. So that gives you -1/2. So -1/2 would be about the value. So I was almost close. I was very close on my graph. It's about right here at -1/2 for the point of inflection. So -1/2, and then how do you find the y value? If you're given your equation, you would plug this into the equation, and then you would find the y value. In this case, we weren't given the equation, so we're just going to kind of look at the graph and see if we can tell what it looks like it's at. It looks like it's about 1.5, so I'm just going to write 3/2. Now, with this, we can now write our intervals. So if we're concave down on the first interval from -infinity to our x value of our point of inflection, so -1/2. And just like when you're increasing and decreasing changes over, you don't include that value for the point of inflection where you're changing from concave up to concave down. That's why I'm going to use a parenthesis. So then the next part, I am concave up because the curve's bending upwards, and for this it's on the interval from the x value of my point of inflection, so -1/2 to +infinity. And then of course I'm going to write down POI I use for point of inflection. So my point of inflection is -1/2 comma 3/2, and again notice that it's a point of inflection, so I'm using an x and a y value. I don't just do some kind of interval. Now let's look at the next one. So for the next graph that we have, same thing. So it looks like we have from here to somewhere in here, we are concave up, and then from here to somewhere in here. It looks like we're concave down, and then from here to here, it looks like we are concave up, and then from somewhere in here to going to infinity, we're concave down. So in this case, we have two places where we're concave up, and we have two places where we are concave down. So we would have to write each of those intervals. If we wanted to figure out where those points of inflections are, we need to figure out our max and minimum points. So this minimum point is -7, -2. This is -4, 3. This point here is 0, -4, and this point here is 3, 0. So basically I'm going to take each of those and find the x value that's going to give me the x value in between each of those. So for the first one I have -7 plus -4 divided by 2, which gives me -11 over 2, which is about 5.5. And then if I do the next one, I have, so that was the first point of inflection, which is right here. Then the second point of inflection somewhere over here. So for the second one, we have -4 plus 0 over 2, which gives me -2. And then for the third point of inflection, we are going to do something in between this maximum and this minimum. So we have, in this case, 0 plus 3 divided by 2, which is 1.5, or 3/2. Now for this, I can figure out what the actual point of inflection is. So I'm going to write point of inflection. I'm going to write them out. So for the first one, I have 5.5. So if I look at my graph, 1, 2, 3, 4, 5.5, it looks like we're at about a half. So 5.5, 1/2, or you could probably say 5.5. Actually, it looks like we're at 0. So 5.5 comma 0. For the next point of inflection, which is number 2, we have -2, and it looks like we're at -1 for the y value. And for the next point of inflection, number 3, which is the last point of inflection, we have an x value of 1.5. And it looks like we're down at 1.5, -2. Now I can write my intervals where I'm concave up and concave down. So I'm concave down on 2 intervals. So again, this piece right here, which is -infinity to the x value of my first point of inflection, which we said was 5.5. And I'm also concave, oops, I put down, I meant to put up there, sorry, not down, but up. And I'm also concave up on the interval from this point of inflection 2 to point inflection 3. So the x value of my point inflection for the second one was -2 to 1.5. And then concave down, we have the intervals from our first point of inflection to our second point of inflection, which would be our first point of inflection, we had an x value of 5.5, and our second point of inflection x value was -2. And then from here and going to infinity, we have the last part where we're concave down. So the x value for the point of inflection number 3 was 1.5 to infinity. I could also, if I wanted to, write the intervals where I'm increasing, decreasing, and constant. I don't have any constants for either of these graphs, but in order to do that, notice that in order to find the point of inflection, I need to know my maximum and minimum points. So maximum and min points are very important to find because it helps you find the point of inflections, which help you then find your concavity, and also they help you find the intervals where you're increasing and decreasing. Note, if there are no points of inflection, then the curve is concave up or concave down on the interval from -infinity to infinity. And if there's a point of inflection, then our intervals for concavity go from, again, the x value from the point of inflection to some other x value. Now, for this next part, we're going to take this graph and we're going to find everything that we've been working on, the x and y intercepts, intervals where we're increasing, decreasing, local max or min, intervals where it's concave up or down, point of inflection, and we'll also practice the domain and range. So of course, the first thing you want to do is get your calculator out and plug this into your y equals on your calculator. Then I'm going to hit zoom 6 for a nice standard window. On this window, it looks like I have everything, but I'm going to just zoom out really quick to make sure. So I'm going to do zoom 3 and hit enter. Once we start learning more about graphs, you can kind of tell, but it doesn't look like I have anything else over there. So I'm going to zoom back in. So zoom 2, enter. And I'm actually going to then zoom in a little bit more around what's going on right here. So I'm going to hit zoom in, and I'm going to take my cursor here and go to where I think the point of inflection is. I just kind of want to get a better window. You don't really need to change the window there, but I'm going to. So I want to then go to my window, and I'm going to change my Y minimum to, I'm going to put it at 0, and the maximum at 10. Okay, so that gives me a nice graph. Now for this, I'm going to find everything that I want on my graph. So my maximum and minimum points are usually, again, the first things that I should find because they help determine everything else. So I'm going to do the second trace minimum first because that's the first place on my graph that I have. So here it looks like the minimum somewhere around here. So I'm going to go to the left of that, enter, and then to the right of that, enter, and then enter, and I have a minimum value of 0.0873, comma 2.9571. So that would be my minimum. And I just realized I put 7.3 and it's actually 7.1. So 0.0871. Then I would do the same thing for my maximum. So second trace, now I want maximum, which is number 4. Whoops. And I'm going to scroll to where I think my maximum is. Something to the left of your maximum would be somewhere on this side. I'm going to hit enter there, then go somewhere to the right and hit enter and then enter. And notice I get my maximum. So my maximum point would be 1.9129. And then we have 9.0429. And again, because it's a maximum point and a minimum point, that's why I'm using the x and the y coordinate. So now I know where my minimum and my maximum value is, which helps me get my intervals where I'm increasing, decreasing. So here on this first part to my minimum, I am decreasing. So I'm decreasing on the interval from negative infinity to the x value of my minimum, which is 0.0871. I'm also decreasing from the maximum here to infinity. So I'm also decreasing from the maximum x value, which is 1.9129 to infinity. If you rather do it in order as you go on your graph, that's fine, so you don't miss any values, but I just put it together in this case. And then from here to here, I am increasing. So I am increasing on the x value of my minimum to the x value of my maximum. And so that takes care of my increasing and decreasing. Now I want to go ahead and find my intervals where I'm concave up and concave down. Remember, to find the intervals where you're concave up and concave down, you're going to want to take your x values from your maximum and your minimum, add them together, and divide by 2. So we're going to take our rounded answers here. So I'm going to go back to my home screen, and I have 0.71 plus 1.9129, enter, divide by 2, enter, and notice that we get 1 for the x value of our point of inflection. So on my graph, I'm going to go to second trace, I'm going to do the value, and then I'm going to plug 1 in for x and hit enter because that's going to find what the y value is at x value of 1. You could also plug it into your equation or look at your table on your graph. I just find it easier to use the value function. So right there is my point of inflection, which remember I use POI for point of inflection, and it's a point, so we're going to do the coordinates 1, 6. Then from there, you can show the intervals where you're concave up or concave down. So from negative infinity all the way to the x value of my point of inflection, notice I am curving upwards. So this would be concave up on the interval from negative infinity to the x value of my point of inflection, which is 1. And then for the next part, from 1 to infinity, we are concave down. So from 1 to infinity. Now I need to find my x and y intercepts. So let's do the y-intercept first. So second trace value, if I do 0 in, because when you plug 0 in for x, that gives you your y-intercept, which is 3. So my y-intercept is at 0, 3. And notice I only have one x-intercept, which is here. It's kind of hard to tell in my graph right now, so probably what I should do is I should change my window a little bit, and I'm going to go change my y value to negative, let's do negative 5, so I can kind of see the x-axis there. Oops, that didn't work. Negative 5. And that gives me a better look at my x-axis and where it's hitting right there. So second trace, we're doing the 0, which is number 2. And something to the left of where the 0 is would be above the x-axis. So I'm going to hit somewhere, enter somewhere over here. And then if I go to below the x-axis, that's somewhere to the right bound, enter. And notice I get an x value of 3, so my x-intercept is x equals 3. And now I want to find my domain and my range. So in order to think about your domain and range, think about the original equation, which was f of x equals negative 2x cubed plus 6x squared minus x plus 3. If I look at this, I have no variables in a denominator, and I also have no variables underneath a radical, so my domain would then be from negative infinity to infinity. And if I look at my graph, I can see that the range is going from negative infinity to infinity. And as we learn more about graphs, I know that it would have been that because when you're working with odd functions, you're always going to have one end of your graph going up and one end of your graph going down, which makes the range negative infinity to infinity when you're working with polynomial equations. If it's a polynomial equation and it's an even function, then your range is not going to be all real numbers. So for even functions, you would have to definitely watch out for that. And you can then use your maximum and minimums, depending on which way your graph is opening, to help determine what the range would be. So for example, if I had an even graph, would have both ends up or both ends down. So if this was my graph, I know that if it's a polynomial function, the domain would be all real numbers, and then I would, for my range, have to figure out what this maximum value is. So my answer would be from that negative infinity to that maximum value would be my range. So being able to do this is very important. If you are, when you're doing your homework, graphing these on graph paper, you always want to find each of these, and of course that means you're probably going to have to change the scales, because if you have a very large maximum or very small minimum value for your y values for that, then you would want to scale your graph a little bit differently. So make sure you bring this with you to class, and we'll go ahead and talk about the next section, which is going to be graphs of piecewise defined functions later.